we have here a little bit of a scenario. We have two schools located at points -1 and 4, as well as 7, -2. So those are the points on a town map. The school board is planning to build a new sport complex to be used by both schools, and the school wants to be equitable and make this sport complex in between both schools. So it's not going to be closer to one or the other, it is going to be exactly between. So before we even begin looking at these questions, why don't we just plot these points? So the first one is -1, 4. So that'll bring me up here. And we'll call this school A. The second one is 7, -2. So across 7 down 2, this is school B. Okay, those are our two schools. Let's get on to the question. We want to find a location that would be equidistant from both schools. So if you remember before, if I have 2 points and I connect them with a straight line, the point that would be equidistant from both those two schools would be the midpoint. Let me just maybe redo my line a little bit. Draw a straight line here. So here's point A, point B. The midpoint is going to be somewhere around here. Let's just call it M. Okay, so let's calculate it. Let's figure out where this sports complex is going to be, called M. If you recall, the midpoint of 2 points is given by the formula x1 plus x2 divided by 2, as well as y1 plus y2 divided by 2. Now if I substitute these values into the equation, okay, the ones up here, I end up with -1 plus 7 divided by 2, as well as 4 plus -2 divided by 2. Do the calculation, I end up with 3, 1. So my midpoint is at 3, 1. Let's take a look here. It looks like it's a little bit off, and my line is off as well. But my midpoint is going to be right here. So let's call this M and draw our line again connecting the two schools. And there you have it. So that's where my sports complex is going to be. Now, we run into a bit of difficulty. Okay, here's the problem. That midpoint, let's say, is actually in the middle. There's a body of water here. Suppose there's a lake around there. So the midpoint is actually in the middle of a lake. Now, we could build a sports complex on a lake, but I'm sure it would cost a lot of money. And school boards these days cannot afford this kind of stuff. After all, they built Bill Crothers, and I think they dumped a lot of money into that. So we'll leave it at that. But are there any other possible locations where I could put this sports complex? Let's take a close look. I cannot build it in here because I'm in the middle of a lake. However, if I were to make a line, say a perpendicular line, through that midpoint, okay, it'll be right angle, and take a point, say at the edge here of that lake, connect it with a line to B and a line to A, that will be, again, the same distance from both the schools. What we have here is an isosceles triangle, and the good thing is that I don't have to just necessarily choose a point right on the edge of the water. If I wanted to, I could move my sports complex, say over here, or anywhere along this line in that direction, and as well on the other side. I can extend it and move anywhere along this line in the other direction. So there are many ways I can build this sports complex in such a way that it's equidistant from both schools A and B. Now what we're going to do is figure out what this line is. And what it's called is a perpendicular bisector. Okay? Perpendicular bisector. Now it's perpendicular because it intersects the line at a 90-degree angle, and it is a bisector because the line divides the line AB into two equal parts. Okay, that's what the three lines mean. It bisects it in half. So if I want to find the equation of that line, I need a few things. First of all, I'm going to write the general form. Y equals mx plus b. And what I need is my slope, and I need a y-intercept. So that's for this line over here, my perpendicular bisector line. So the slope, well, let's start with that. I don't have any points on this line yet, but I do know how to figure out the slope, because if I know the slope of AB, well, the negative reciprocal will be the slope of the perpendicular bisector. So why don't we find the slope of AB first? So the slope of AB is going to equal, and I'm going to forego the formula and go right into substituting in my points. I have -2, so y2 minus y1, which is 4, over 7 minus -1, x2 minus x1, which gives me -6 over 6, which equals not over 6, it'll actually be over 8, which gives me -3 over 4. So the reciprocal of -3 over 4 is then 4 over 3. That's the negative reciprocal. And that's what I can substitute into my equation for the perpendicular bisector. I will have a 4 over 3 here. Next, I need a point on that line. And currently, if I look at my diagram here, I have no point on this perpendicular bisector. However, I do know that the midpoint is going to be on that line, and I can calculate the midpoint using the midpoint formula with points B and A, the two schools. So let me do that first. Let me calculate the midpoint M. Well, actually, I already did that above. You don't have to do any work. So we can actually use this midpoint, M here above, and substitute into the equation to solve for B. So what does that look like? I get 3 for y equals 4 over 3x. Actually, it's not 3 for y, it's 1 for y. 4 over 3x, which is 3, plus b. The 3's cancel out. The 4 comes over. I get 1 minus 4 equals b, which means b is equal to -3. And my equation is y equals 4 over 3x minus 3. So there you have the equation of the perpendicular bisector. And that's the